The fun stuff happens when we look at how variables are related to one another. There are lots of different tests out there, and we're only going to cover the most common. We'll start with crosstabs and the chi-square statistic. Then we'll talk about t-test and an extension of the t-test called ANOVA. Then we'll turn to correlation analysis. And which test you use depends on the types of variables you have before you. All of these tests are in many ways precursors to the regression analysis, which is the real heavy hitter, but it's often useful to work in these mini steps before jumping into regression. At core, we're asking how one variable impacts another. We've actually already hinted at this in the univariate unit. Remember me asking you to graph food spending by number of children in the home? To confirm those differences, that question would call for a t-test. For all the techniques we're going to look at, the important question is a subtle one. Are the trends we see meaningful? In other words, are the trends due to more than just random chance? If it's just random chance, we really don't care. So from here on out, we're going to have a companion on our journey. Nearly every test or technique we will use will have an associated p-value. The p-value tells whether the outcome of the technique used is statistically significant. In short, the p-value tells you whether the test you've done is even worth interpreting. So always start with the p-value. Technically, the p-value tells you the probability that the associated outcome is due to random chance. The lower the p-value, the less likely the association shown in the test is simply random, and therefore the more likely the trend is meaningful. That's a little counterintuitive, so let me just say that bluntly. We want a low p-value. Which begs the question, okay, how low? The actual threshold we want is a bit open to interpretation, and in truly rigorous work should be based on the sample size and the types of variables being considered. But the common rule of thumb is a p of less than 0.05. A p-value of 0.05 means there is only a 5% chance that the given outcome in our test is due to random occurrence. And for the most part, we say, all right, I'll take those odds. In fact, the convention goes a bit further. We often use a 3-star system to indicate the strength of the significance. At 0.05, we give it 1 star. It's significant. If p is less than 0.01, that is, there's only a 1% chance that this finding is due to randomness, that's 2 stars. It's very significant. And 3 stars appear when p is less than 0.001. In other words, 0.1% or 0.1% chance that the association is simply random. That's hella significant. Since the p-value applies to nearly every technique we'll discuss and is interpreted in the same way, it makes sense to start with that, both in teaching this unit and in interpreting any test you do. The rest of the videos in this unit for the next few weeks are going to follow this pattern. We'll talk about the theory behind the method, we'll talk about how to interpret the output, and then I'll talk briefly about how to apply this method in R, but a lot of that will probably come in live class sessions where we can talk through some of the particularities of the code we're using. What we're going to start with is a focus on crosstabs, and then move into thinking about t-tests and their logical extension, ANOVA. Then we'll turn to correlations, and then finally we will arrive at the real heavy lifter, regression analysis.